Special right triangles. This is chapter 8, section 3. What do we mean by special right triangles? Well, the fact that they're right triangles means that they're going to have a 90-degree angle in them. So what makes them so special? The first kind is called a 45, 45, 90. Again, that 90 is pretty obvious since it's a right triangle. So our other two acute angles are both the same. They're 45 degrees. So what kind of triangle would this be besides just saying it's a right triangle? Based on leg size, how would we classify this? If both angles are the same, that means both legs are the same. What kind of triangle has two legs the same length? It would be an isosceles triangle as well. So the legs are the same length. Okay, that goes along with what we learned a long time ago with respect to triangles. If the base angles are the same, then the leg lengths are the same in an isosceles triangle. So automatically you should see this as isosceles and know that those two leg lengths are going to be the same. And the hypotenuse is square root 2 times as long as the leg. So whatever the leg length is, your hypotenuse is going to be square root 2 times that. So here's my two leg lengths. They have to be the same. And then all I do is put a square root 2 after that for my hypotenuse length. So it's real easy when you're going that direction. When you're going from leg to hypotenuse, think about this. Is the hypotenuse longer or shorter than the leg? You should know that it's longer. The hypotenuse is the longest side of a right triangle. So we're going to multiply. If we're going from leg to hypotenuse, from short to long, we're going to multiply by the square root of 2. What would we do if we were going the other direction? You need to think about that because we will be having to do that. But let's do some more going from short to long. Okay, so here's my triangle. This side is x. That means this side's going to be x. So this side is x square root 2. Okay, that is the general formula for a 45, 45, 90 triangle. This is what you would see on a formula chart somewhere. So whatever number I plug in here for x, I'm going to plug in here and here. They're all three going to be the same. But that hypotenuse is square root 2 times. In other words, you're taking this number over here, you're taking 3 and you're multiplying it by square root 2. If you did that in your calculator, you would get a bigger number than just 3. So the hypotenuse still has to be longer than the two legs. Okay, so if you have this isosceles triangle, we know that these two are the same, so that tells me they have to be 45, which means my two legs have to be the same. What is the length of my hypotenuse? Okay, well, we could figure it out using Pythagorean's theorem. A squared plus b squared equals c squared. And we could do that all out and go through all of this math. Remember, I can write 50 as my perfect square 25 times 2. What is the square root of 25? It's 5. Still have my square root 2. So my hypotenuse is 5 square root 2. So I could go through all of this, but all this is doing is proving the pattern that we've already stated. Whatever the side length is, I'm just going to put a square root 2 after it, and that is my hypotenuse length. Okay, so again, this is the general pattern for a 45, 45, 90 degree triangle. You need to know how to use it. Okay, so find the missing sides. What is this leg over here going to be if it's 45, 45, 90? If it is an isosceles right triangle, this has to be 7. And then all I'm going to do is put what after it? Square root 2. So there we go. Okay, what if I give you the hypotenuse, the long side, and I want you to go to the short side? Okay, well, if we go short to long, we're multiplying. What are we going to do if we go long to short? What's the opposite of multiplying? Dividing. So I'm going to divide by that square root of 2, and this is what it would look like. 8 square root 2. Remember, a fraction is division. Well, anytime I have the same number on top and on bottom, I can cross them out. Remember, square root of 2 is a number. That is something I can punch into the calculator, and I will get a decimal. So treat it just like another number. Treat it like a 2 as far as canceling goes. I have 1 on top. It's going to cancel with the 1 on the bottom, and all I'm left with is 8. So that is my leg. Whatever this leg is, that is also my other leg. So they're my 8s. Now your hypotenuse may not have a square root 2 after it, but I'm still going to do the same thing. If I'm going from long to short, I'm still going to divide, and I'm still going to divide by the square root of 2. So I take my 10 and I divide it by the square root of 2. Now, you're really not supposed to have a square root on the bottom. In order to get rid of that square root, I got to multiply it times itself so that I get a perfect square inside. That way I can pull it out. Well, I can't just go multiplying part of my fraction by some number. I got to multiply the top and the bottom. Remember, anything over itself is 1, so I'm not changing the value of this fraction. I'm just multiplying it by 1, and I just need that 1 to look like my denominator. So here I get 10 square root 2. I just put them together. What is the square root of 2 times the square root of 2? Well, it's the square root of 4. Can't do anything up top. 10 square root 2. What is the square root of 4? This will always come out to be a perfect square when you do this. That's the whole point. The square root of 4 is 2. Now, I can reduce this 10 over 2. Do not cross out a square root of 2 with a regular 2. They are not the same number. Nowhere near. So don't do that. But 2 will go into 10 5 times. So I get 5 square root 2. Here's the reduction, 5 square root 2. Okay? Do I need to explain that again? Let me erase all my markings so you can see maybe a little bit neater. Okay, so we took the 10 and we divided it by square root 2 because that's what we do in a 45, 45, 90. It's always relationship is square root 2. But I can't have a square root of 2 on the bottom, so I have to multiply it by itself so that I'll get a perfect square inside there. The whole number times the radical just stays like that. I cannot put those two together. Do not tell me that is the square root of 20. It is not. Okay, where did this 2 come from? Because the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. Now I can reduce to 5. And my final answer is 5 square root 2. In both positions. And that's the length of both legs. The second kind of special right triangle is the 30, 60, 90. Again, the 90 is understood because it's a right triangle, so that's no surprise. but my other two acute angles are going to be 30 and 60. So what's the relationship here? Okay, there's two different relationships. The hypotenuse is twice as long as the short leg. And the long leg is square root 3 times as long as the short leg. Okay, again, wah, 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 Charlie Brown's teacher. Let's see it. Let's look at it. See what this looks like. So the general equation is something like this. You take your short leg and you double it. So I'm going to go from the short to the hypotenuse. Obviously, since the hypotenuse is bigger, I'm going to multiply. And in a 30, 60, 90, you're going to multiply by 2. When I go from short leg to long leg, again, I'm getting bigger, so I'm going to multiply. This time I'm going to multiply by the square root of 3. So whatever number my x is, that's where I'm going to put in all three of these positions. What would I do if I go backwards? If I'm given the hypotenuse and I need to find the short leg, I'm not going to multiply by 2. What am I going to do? You should be answering these questions in your head. I'm going to divide by 2 because they're opposites. I'm going opposite directions. I do opposite functions. If I go from short leg to long leg and I multiply, then the opposite direction of long to short is going to be division. Divide by square root 3. Okay, so let's see what this looks like in practice. So here we go. Find the length of the missing leg. Okay, here's my pattern. Short leg, hypotenuse is twice that, long leg is square root 3 times that. So what is square root 3 times 5? Just 5 square root 3. Follow the pattern. X is 5. These are in the same position. Now, anytime we have two sides of a right triangle, we can always solve by Pythagorean theorem. So what do we get if we do that? Okay, we know this is the hypotenuse because it's opposite of that box. That's going to be in the C position. Then I put my other two legs on the other side. Square everything. Okay, and then I just subtracted. If I square 100, I'm skipping some steps here because I'm assuming you know how to do this. Okay, a square 50, or I'm sorry, a square 5. Then I have to subtract the 25 from both sides. So that's what I'm doing here. I'm subtracting 25. So when I subtract 25, I get 75, and then remember I got to take the square root to get rid of the squared. What perfect square is in 75? Remember what your perfect squares are? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7, 49. Okay, you need to be thinking of these. Which one of these goes into 25 even, or 75 evenly? Just said it. Okay, it's going to be 25. I can rewrite 75 as 25 times 3. Now, this being a perfect square, what is the square root of 25? It is 5. But I still have the square root of 3 because I can't do anything with that. So, look at what my long leg turns out to be. It follows the pattern. All I had to do is take my short leg and put a square root of 3 after it. You can do it this way if you're just into doing more work. Or you can choose to memorize the pattern and make your work way less and way shorter. Okay, so here's the general pattern. Again, you should have this written down somewhere to refer to. Be able to use it. If we're going from long to short, we're going to divide we're going from short to long, we're going to multiply. Actually, we're not going to go this way. Short to long, you got to ask yourself, am I going short to long? Then we're going to multiply by square root 3. Long to short, we're going to divide by square root 3. So if we need to go to hypotenuse to long leg, we're going to have to go the short leg first. That's the way I want you guys to do it. So here we go. Find the missing side lengths. Okay, this is the short leg. How do I know? Number one, the way it looks, but it's also opposite that smaller angle. Remember, we learned about inequalities in triangles. The side opposite the small angle is the shortest side. The side opposite the bigger angle is going to be the longer side. So I know this is my short side. What do I do to my short side to get to my hypotenuse? I need to double it. So 8 times 2 is 16. What do I do to go from my short side to my long side? Am I going to multiply or divide if I'm going from short to long? I'm going to multiply. What do I multiply by? The square root of 3, because here is my pattern. Again, you need to know this pattern. The short side is x. Hypotenuse is twice that. Long leg is square root 3 times that. So I'm just going to take this 8 and put a square root of 3 next to it. Do not do this out on a calculator. I do not want to see decimals. You need to leave it in radical form. Okay, what about this one? I need to go backwards. I'm given the hypotenuse. How do I find the short leg? Am I going to multiply or divide if I'm going from long to short? Hopefully you said divide. What am I going to divide by if it's the hypotenuse? I'm going to divide by 2, so this becomes 6. Now that I know my short leg, I can multiply it to get to my long leg. What am I going to multiply it by? Hopefully you said the square root of 3. So I get 6 square root 3. Okay. This one looks different. Okay, but we're going to think through the same way, same process. Hypotenuse to short leg. I should divide by what? So 10 divided by 2 is 5. I cannot do anything with that square root of 3, so it stays there. Short leg to long leg. Am I going to multiply or divide? Short to long. I'm going to multiply. So I have 5 square root 3. What am I going to multiply by? I'm going to multiply by the square root of 3 because that's what the pattern tells me to do. And I will let you use your patterns on your homework on your test. Okay, now, what is the square root of 3 times the square root of 3? 3 times 3 is 9, so it's the square root of 9. Well, that's a perfect square. What is the square root of 9? It's 3. So I can multiply this out and get 15. So I shouldn't see 5 square root 3 square root 3. I should not see this on your paper. You should know that the square root of something times itself is going to be just that number that's inside. If I did the square root of 5 times the square root of 5, I get 5. Why? Because this equals the square root of 25. And the square root of 25 is 5. So anytime you're multiplying a square root times itself, your answer is going to be whatever that number is inside every time. Okay, let's do another one. Okay, this one's interesting. This is my long side. If I go from long to short, should I multiply or divide? I should divide. And what am I going to divide by in a 30, 60, 90-degree triangle? I remember the 3 because of the 30. 45, 45, 90 is the square root of 2 that we deal with because there's two 45-degree angles. So that's one way to keep your square roots kind of straight in your head. So this is going to be 8 divided by the square root of 3. Now remember, I can't have that square root of 3 on the bottom. I need to multiply by itself. And whatever I do on the bottom, I have to do on the top. So I'm multiplying by 1 here, but it has to look like my denominator. Now what is the square root of 3 times the square root of 3? Square root of 9, which is 3. And I just have to put these two together. I cannot add or multiply these two numbers at all. Do not tell me this is the square root of 24. It is not the square root of 24. So here I get 8 square root 3 over 3. Well, if I go from short leg to hypotenuse, am I getting longer or am I getting shorter? From short leg to hypotenuse. Hypotenuse is the longest side, so I'm getting longer. I'm going to multiply, and I'm going to multiply by 2. Well, all you're doing is multiplying the 8 by the 2, and you get 16. So my hypotenuse is 16 square root 3 over 3. Una más. Okay, we're doing the same thing. I go backwards to the short, so I've got to divide by square root of 3. 12 divided by square root of 3, can't have the radical on the bottom. I multiply by square root of 3 over 3 to get rid of that square root on the bottom because I just pull out that 3. That's my short side. 12 divided by 3 is 4. So my short side is 4 square root 3. What do I do to the short side to get to the hypotenuse? I double it. What is 4 times 2? All I do is multiply the 4. So I get 8 square root 3. Last one. Okay, this triangle is oriented a little differently. Is this the short side or the long side or the hypotenuse? It's the long side. How do I get from long to short? Divide. What am I going to divide by? Square root 3. So I'm just taking this and I'm dividing it by the square root of 3. Well, look, I have the same thing on top and on bottom. I can cancel those out, leaving me with just a 5. How do I go from short side to hypotenuse? Am I going longer or am I getting shorter? Getting longer, so I multiply by 2, which gives me 10. So bottom line is you need to be able to go in all directions on a 45, 45, 90 where the legs are the same and the hypotenuse is square root 2 times that. Also on a 30, 60, 90 where the short leg is x, hypotenuse is twice that, and the long leg is square root 3 times that. Be able to use these patterns on your homework. All right, have a good